Students, next topic is conservation of mechanical energy. In this topic, we will take one example in which a wall which is above the ground at height h, this is the ground, and wall is situated at this point A, and its height is h from the ground. At this point, as it is falling freely under the effect of gravity, its initial velocity u equal to 0, and its potential energy at this point will be equal to mgh. So total energy at point A equal to potential energy plus kinetic energy. Its potential energy is mgh at this point and kinetic energy is 0. Therefore, the total energy will be equal to mgh at point A. Now, as this ball falls freely under the effect of gravity, and it will follow certain path at a particular time, it reaches to point B. This point is below the point A by a distance x. Now its height from the ground is h minus x. At this point, it will acquire some velocity, and suppose at this point its velocity becomes v, and its height is h minus x. As this ball has the velocity at this point, therefore it will have some kinetic energy and it will have some potential energy. So we have to find what is the velocity acquired by this ball at this point v. That can be obtained by third equation of motion, and that is v square equal to u square plus 2gh. As the initial velocity of this ball at point A was 0, so it will be equal to 0, 2g, and at this height it falls by a distance of x, therefore distance will be equal to x, and this is equal to v square. Now what is its kinetic energy at this point? That is obtained by half mv square. This is the kinetic energy, and half m, and value of this v square is 2gx. Therefore it is equal to mgx. And its potential energy at this point B, is equal to mgh minus x. Therefore the total energy at point V is equal to potential energy plus kinetic energy, and this is equal to mgh minus x plus kinetic energy is mgx. When we open this bracket, mgh minus mgx plus mgx, these two mgx are cancelled out, one has the negative and the positive, therefore the total energy will be equal to mgh. At point A, the total energy is mgh, and at point B, the total energy is mgh. Now in the same way we can find out the total energy just above the ground, and this is point C. At this point C we can find out the total energy of this ball. First we find out the velocity at point C. In the same way, from the equation v square equal to u square plus 2gh, as the initial velocity is 0, now it falls by a distance h, therefore it will be equal to h v square, or v square will be equal to 2gh. What is its kinetic energy at this point? Kinetic energy equal to half mv square, and this is equal to half m into 2gh. We can put this value here in the place of v square, and this 2 is cancelled out, mgh. And what is the potential energy at point C? That is equal to 0, because its height at this point, as it has reached to the ground, therefore its height will be equal to 0, and therefore its potential energy becomes 0 at this point. Now the total energy will be equal to kinetic energy plus potential energy, and this is equal to mgh plus 0 equal to mgh. So hence we see that the total energy at point ABC, A, B and C is same, and that is equal to mgh. Therefore, the total mechanical energy is conserved throughout its path, and that remains constant. It proves the law of conservation of mechanical energy.